Hi everyone, hope you can see me. Really nice to meet you, and thank you for joining the webinar on ROBBO. I would recommend you all to switch off your microphone so that you can actually hear me well, and then as soon as we will join the Q&A block, then we can discuss it further, and you can switch it on again. So let me introduce to you myself. My name is Kristiina Karkkanen, and I'm managing ROBBO Europe here in Finland. It's pretty sunny weather outside. Let me just start with the presentation. And I would ask you all if you have some questions, and if there will be question which will be reason during the conversation, just write them in the chat, which can be found in the left upper corner, and then I'll try to answer them as soon as I have time and we have Q&A session on. So let me share first my screen with you and show you the presentation of ROBBO. So yes, ROBBO, and Code Your Imagination. So ROBBO was designed by the group of really creative people and professionals in their area from Russia and Finland in 2010. But the experience of this group dates probably already from 2000. Robots are unique robotic platforms which are educational tools and which are designed for anyone from the age of 7 to the age of 99 to learn programming, basics of technology and engineering. The products are based on the open source principles, so that actually helps and encourages our users to learn in depth the technology they are based on. The market. Let's just take a bigger look at what is happening in the world. It was estimated by the International Federation of Robotics in 2015 that the market of robotics will grow annually by 30%. In 2015, it was about 5.3 billion euros, and the highest demand in the future is expected in educational and personal sectors. So it means that educational robotics will be growing, and the demand for it will be growing and driven by the market. Even right now in Finland, where we are located, you can notice that the buzz and the boom of programming and robotics is growing from the beginning of 2000, beginning of the educational year. So it's in August 2016. The programming will be introduced as a compulsory subject in Finland. So children will be obligated to learn basics of it. Right now there are a lot of different options on the market, but a lot of them are based on the proprietary software and hardware. So it means that they are based on the black box technologies that you cannot actually understand what they are built of and how they actually work. And our users don't even try to ask questions what they are made of, because they don't get this kind of a spark by looking at these technologies. So we, in the end, have the user, and we become a user, but not an innovator or the how would say the engineer, the beginning of being engineer, to actually evolutionize, like to revolutionize those technologies. So our vision, the vision of ROBBO, we believe that the devices should be understood in depth, that the software and hardware should be open source, and that anyone has an access to it. And this actually helps you better understand the world we are living, to understand the world we are living in. So what we have in ROBBO, our products, they are based on, as I mentioned, open source technologies. Arduino microcontroller is at heart of our hardware, and we have several different programming environments which are applicable. Most of the software made for Arduino is actually applicable to our product as well as Scratch, which we a little bit developed and updated to use with the robots. So based on our experience and based on the knowledge which we received throughout the years, that these kind of products actually encourage abstract thinking and problem solving in the users. Our products are both supported by educational materials, and I will talk about it a little bit in details later. So let me introduce you the ROBBO kit which ROBBO has. This is the first product which was developed and the star of the line right now. It's a customizable robot construction kit. It has 5 places for magnetic mount sensors. You can see it on the picture. It looks a little bit brutal, I would say, but as I said, we try to avoid black box technologies, and we try to show everything and actually provoke questions about what it is made of and how it's made of. And the product is developed to teach users programming and robotics. More advanced users, of course, can dig deeper into the mechatronics, but we don't touch the subject for now. The package of the ROBBO kit comes with the 6 different sensors. It has actually LED, the flashlight, which is not a sensor, but for younger users, it's easier to understand what is LED and flashlight. Then we have light sensor, touch sensor, proximity sensor, and 2 line sensors. So it means that the robots can be applied in different competitions. They can follow maze. They can have different competitions like sumo fight or even football, robo football. The laboratory is a little bit simpler, but at the same time more advanced, I would say, robot. It's a microelectronic board which has already built-in sensors. It has several LEDs which are built in. It has sound sensor, speakers, and 5 programmable buttons, which you can see on the picture. All of the components which are on the board are programmable. And actually, we have connectors for the Arduino shields, meaning that our advanced users can actually use and utilize their own inventions with the lab and start programming them apart from the Arduino IDE own programming in environment, also program them in Scratch, for example. So enough about hardware, a little bit more about the softwares for the users which are not familiar with the Scratch. This is the primary language which we recommend to start learning programming. The Scratch was for decade with us, and it was developed by MIT Media Lab. It is translated in dozens of languages, and For this Scratch, we had to a little bit update the protocol in order for it to be used with our robots, but it fully works as a Scratch with the different characters there, and also it can be used with laboratory and RoboKit. You can see that like there is a gray block which is actually developed specifically for lab, and it's under in written lab button. So far the blocks for RoboKit and lab we had to translate ourselves with the help of the native speakers and the teachers. It takes about 24 hours to develop languages further, because even though there are already existing languages within the system, still for the new blocks we have to update it ourselves. But everything is customizable, so it can be applied anywhere. Then ArduBlock. A little bit about the ArduBlock. It's a graphical language for Arduino, since our hardware is based on the Arduinos. And I believe that this is a really nice tool for the evolutionary process of learning. So it means that from the scratch, ArduBlock would be the next step to advance in programming. It combines graphical and textual languages. Textual language is Arduino IDE, or which is C++, which is commonly used programming language. And you can see as on the picture that the blocks in the graphical ArduBlock are really close to the Scratch, and there are a few differences which should not influence anyhow badly on the transition from Scratch to ArduBlock. And then Arduino IDE, the programming environment, which is actually the most advanced one, which can be used right now with the robots, and it is actually allows to upload the code into hardware right away. So the robots will be working autonomously, like, for example, many probably know about Lego, that you can upload the code there. The same way it works with the Arduino IDE. I mentioned that we have educational materials. So the products are supported with educational materials. Right now, unfortunately, during the May, there were some delays that we couldn't publish the educational materials yet. They are in the final stage of updating layout. They've been developed with Helsinki University, Department of Teacher Education, and Finnish secondary schools from the Innekas network. Innekas network is a big network of teachers, academics, and just technology enthusiasts, which try to develop technology education, STEM education in Finnish schools. The robots were, the schools were in our pilot project with Helsinki University, and they've been working with our robots. Helsinki University was just guiding them through the process, but most of the information which was put, and the ideas and innovations which were put in the educational materials were developed by teachers and students in particular. And the students were actually developing the material, adding their different challenges. How make out of the basic exercise something what can be applied in real life situations, like, for example, crossing the roads, pushing the button, or something like that. Enough about our product, but a little bit about the project. We have been actually awarded twice by Google Rice Awards. Both products, Lab and RobotKit, were noticed by them, and we received the grants. Also, in 2014, the project won Finland in competition which was organized by Finnish Ministry of Employment and Economy for high-tech companies from Russia. So, as I mentioned, our key partners in developing this project are Finnish universities, academics, and teachers from the INNECAS team. So, the product which you have seen right now was actually influenced by all these partners. And of course, I didn't mention most of the schools and students which were there, but I always thank them, and I cannot thank them enough for helping us to develop the product which we see right now and which is used right now. So our products are available for purchase. Right now we have a discount till tomorrow, till the end of tomorrow. So it's 10% discount on buying the set of products, ROBBO and Laboratory. We have also for schools, clubs, and other educational entities special services specifically organized for them. It means that we support them in installation of all devices, software and hardware. We have personalized support for teachers, students, and rectors, whoever needs our advice or support. And then, of course, we organize teacher training if it's necessary. But actually, the community growing really, really fast. So at some point, we see that there will be not so many need of us being there, but as of teachers being there for the teachers. So here's our contact information. Mine in Europe, and then for those of you who are interested, also there is a contact information of the manager who is leading the project in Russia right now. So let's make it less of monologue and more of the question and answers, because probably I didn't answer all your questions with this presentation, and I would like to learn a little bit more of you. So if you have already questions, and I see that there was just a technical problems, but from Marta. But anyway, do you have any questions, and what kind of questions do you have, so like that we can actually develop a little bit our communication here? I know that there are some of the Finns and our users here, and do you have questions? Oh yeah, at which I have first question, so I'll answer that, and then my Finnish friends who've been using already ROBBO can actually ask or share their experiences. So Sahil, nice to meet you. You ask at which grade we can introduce ROBBO. I would say if we start with the basics, then as soon as the child reads, as soon as the child understands how to use computer, actually, because right now we don't have application for the robot. We have it for the older versions, and for new versions we wanted to make it user-friendly so that children at the age of 6 or 7 can already apply their knowledge and start developing their programming skills. And of course 99 would be the limit, but it's just precautious. Any more questions or experiences? Maybe feedback. I know that also wanted to mention that this will be a series of the webinars. So it means that today we just introduce our products and introduce the project, but later on we'll have quick intro of programming in these different environments which I talked about today. For example, Scratch, basics of Scratch, and RoboKit, and laboratory basics of connecting actually both products. And of course, then we'll jump into ArduBlock, or for those of you who wants to just use the Arduino, we can also share Arduino, some of the possibilities, like how to use robots with Arduino. I know that I had received a couple of questions about that, and I'm a little bit slow with answering to everything, but I will be in contact with those of you. So for now, while we are all shy a little bit, I wanted actually to show you how the products come into to their customers. So this is the Robbo package of the RoboKit. So we have a 3D picture of the RoboKit with all the parts, 5 sensors attached to the platform. Also, I didn't mention, but the products are used with a USB cable. We use micro USB and normal USB to the computer, but they can be also connected via Bluetooth. So it means that the connection can be developed over the Bluetooth, obviously. But what I would suggest with the children, and what we've noticed, that it's best to start with the USB cables in the beginning, actually, and then just go into the programming over Bluetooth. The RoboKit actually has 3 buttons on front. I cannot show you, unfortunately, right now but oh, actually, I can show you, sorry. So in front, there are 3 buttons. One of them is a start button. So it means that you can program this button for robot to start the program without even cable attached, or without even giving the any sign from the Scratch or Arduino. And then, of course, there is a battery on-off. So it means that we can connect battery. 9V rechargeable battery is recommended for this device, because the motors are so fast that they can eat up the whole battery, and with children that was a problem. And then, of course, reset button, that just a precautions for everyone. So just to show you, there is a Bluetooth, there is a connector via USB, there is a battery connector, and 2 motors. I will just show you about for our magnetic mount connections, how it's done. So the robots, so this is a line sensor, and I can attach it to any place on the robot designed for the sensor, just like that. And of course, I'll finish showing you the package. That robot comes in this kind of package with sensors and the USB cable. We don't put batteries inside, just for the reason that we suggest to use the best ones on the market for that. And of course, each of the product has the manual. It can be in English, Swedish, or Finnish for now, but depending on the market, of course, they will be translated and developed further. Let me get into the question of Marta. Did we already plan some experience with ROBBO? What kind of experiments do you mean, Marta? Can you a little bit elaborate the question? Because experimenting at school, there were a lot of tests done with the robots. They've been falling. They've been actually used outdoors with children, and we're actually having the academic research ongoing with the Helsinki University, and we will receive the results by the end of August. or no, results will be by the end of May, but the report will be compiled by the end of August. And we were actually studying um, actually effects and motivation if our robots actually motivate and work with the students, and how they work, what kind of results could be received from that. We already had some good feedback. Over the weekend we had a big event happening in Finland, and we've met a couple of our students who've been participating in the pilot. One of the children said that they have different robots at their school, and they are actually interested to have this kind of robots at home, because it is possible to dig deeper, to jump into textual programming environment with the robot, and that there are no limits to creativity and to application of the robots so far. But it's just numbers, so a few numbers of the Finnish students. And they wanted to mention also the students in the pilot project were from the 2nd grade to the 9th grade in Finland. So it is the age of 8, 9 to the age of 16, I think that was the eldest. Programs, exercises with kids. Yes, we have, in Finland we have right now 5 schools, 6 classes, different classes, as I said, from the primary level of the 2nd, 3rd grades to the secondary higher, so it's 9th grade here, age 15, 16. In our pilot project, Helsinki University was developing the outline of the exercises, dividing it into different blocks, modules, and they put some ideas of what could be done in this module from their educational perspective, because we are working in particular with the Department of Teacher Education. And then the children and the teachers were developing those exercises. And afterwards, Helsinki University was gathering results and was conducting interviews and different questionnaires during the educational processes as after them. Hopefully I answered your question. Do we have any other questions? Okay, I got you answered the question. Thank you, Marta. Any other questions? Right now, if I can say a few words about where robots have been already sent, what kind of new homes they have. I would say we cover right now a lot of European countries and actually Asian countries as well. There were a lot of interest about the product from different educational environments, so I mean clubs and actually schools. In particular, Finland is very interested because of the whole educational change. But also some of the robots were sent to UK, where the programming also is part of the secondary education. I didn't mention, and what right now I remembered to answer, to tell you about. So I talked just about 2 products which are in line. And our vision is to have the whole innovation class in the future. So right now we don't stop our development just on the hardware which we have, but we're preparing a few different projects like 3D printer and digital laboratory. The 3D printer is Also, all the products are open source. All the products are actually designed to be redesigned and designed to be copied and designed to be actually innovated and developed further by our users. Because all the blueprints are available on the internet. 3D printer right now, we already have working prototype, and it also programmable. It means that children can learn programming in 3D environment. 3D printers can actually, that 3D printer can actually copy itself, reprint all the parts of itself, and also reprint all the parts of our product, of the robot kit, of the laboratory. The only thing which will be missing is, of course, the components, but the component list is already available for anyone who is interested in actually digging into electronics more. The laboratory, the digital laboratory, is part of the movement of Internet of Things and is connected to the internet. Actually, it gathers a lot of gathers information from the surrounding environment through different sensors, and afterwards collects it on the server, and then afterward it actually compares it to existing ones on the internet. So it's still in development. We have a working prototype, but as most of these technologies which appear on the market, they have to have a solid application. And that's what we are working on, as well as the materials, teaching materials to support those products. I think I covered like all of the things possible. Any more questions? Otherwise, I think that we can end this session here now. But you, of course, will be able to comment and ask more questions if something comes up later on, and on our YouTube channel, or of course write to me straight if you are interested in talking more details. So thank you very much for your participation. Thank you for spending 30 minutes with me and sharing your time with me. I hope you enjoy the afternoon or the time of which you have right now there, and let's be in contact. Thank you. Bye.